Fever is one of your body's initial response to infection and is common in illnesses like influenza or COVID-19. An individual exhibits above normal temperature shall be denied entry and subject for isolation for further evaluation. According to health practitioner that we have been consulted from Philippine Heart Center, all industry from airports, hospitals, and all public buildings implemented temperature screening on every entrance point to detect person with elevated body temperature. However, they are seeing risk by the possibility of exposing the safety officers or security guards to have close contact to an infected person and vice versa. And they also noticed the incorrect use of non-contact infrared thermometers such as thermal scanner. Medical practitioners seeing high potential using thermal cameras to lessen close interaction from the person being checked. Unfortunately, existing thermal imaging system is highly expensive for most businesses and settling to thermal scanner which only checks single point area on the skin surface. An automated temperature monitoring system will help more to support the objective of pandemic prevention as industries are reopening. From the initial surveys that we conducted, we got insight that many are personally preferred a quality technology that in line to their budget. Second, functionality of the product should be able to solve their problem. Third, a design system that is easy to use. Fourth, a product that performs its function consistently over time. Fifth, a thermal imaging system that can access remotely to give quality customer service to customer and vice versa. Sixth, ensuring that the data collected is protected and solely for healthcare purposes only. Lastly, its effectiveness on how to improve our response during this pandemic. From the said problem, the researchers formed an idea to develop a low-cost thermal camera system while integrating it to an already installed establishment CCTV cameras. The thermal camera used for this project requires an FDA 510K clearance, allowing to use as a supplementary screening tool and have a great laboratory temperature accuracy calibration. Person being screened must be one at a time and should not be used for multiple temperature screening. Developing a CCTV and thermal user application that can be easily read by the operator. The system must have real-time alarm for detecting individual having temperature above 37.5 degrees Celsius. We turned all the gathered data into the development of thermal and true imaging for temperature monitoring using infrared thermography and closed-circuit technology, which relies on already installed CCTV camera and low-cost thermal camera module. However, constraints arises upon the development of the project. First, environmental conditions must be controlled while testing. Second, the CCTV camera that the proposed system can only be integrated directly when it's an Internet Protocol CCTV camera that is UNBIP compliant. Black body equipment is not used in testing as it is highly expensive. However, an alternative thermal output calibration would be performed using contact thermometer. Checking of multiple people in front of the thermal camera is not recommended as it affects the output accuracy, and social distancing must be prioritized. Lastly, data collection must be intended solely for identifying individuals exhibit above normal temperature. Multiple persons can overlap each other's body heat map. Therefore, our main design trade-off is where our system can do multiple temperature screening, but the proponent stick on one at a time evaluation, in accordance to the industry standard the deployment, implementation, and operational guidelines for identifying febrile humans using screening thermography. This to ensure accuracy and prioritize the new normal protocol, social distancing, and help to minimize the transmission of the virus. For the construction of the project, we have three main hardware: the IP CCTV camera, clear lepton 2.5 thermal camera module embedded with a Raspberry Pi 4, and a router. For the prototype purposes, we have purchased 5 megapixel IP CCTV camera. Our proposed system is that IP CCTV and thermal camera are connected in one router that acts as the common data passage. Through the router, these three devices are connected in one local area network using RJ45 Ethernet cable instead of Wi-Fi connection to minimize packet losses. Through Python programming, we access the CCTV feed that will be used for displaying real-time video streaming and taking snapshots of TrueColor images for the application. On the other hand, thermal camera that we use has 160 by 120 pixel resolution and capture body heat map frames for 9 times per second with laboratory accuracy of plus or minus 0.5 degrees Celsius upon purchase. Raspberry Pi 4 receives data from Clear module 9 times per second and temporarily stored it in an open source web database to avoid data congestions instead of processing all the thermal data in the computer. On the upper part, the square boxes is for the CCTV RGB video stream and thermal camera stream. On the lower left side, it is dedicated for daily temperature statistics and customization of the bounding boxes. The 4 consecutive boxes is for the CCTV image snapshots with time information and corresponding temperature from thermal camera. After setting up CCTV thermal camera, a person entering must stand in front of the CCTV thermal camera with at least 3 seconds to get the individual's body temperature in snapshots. The CCTV thermal camera's visual and acoustic alarm will only be activated if the thermal registered is above 37.5 degrees Celsius. The only data collected are the data log in text format of daily monitoring statistics that includes information of the date, time, temperature readings, image, and heat map of the person exhibits elevated body temperature. As the prototype and software application already built, to validate the accuracy of the thermal output, we perform an inexpensive calibration check using contact thermometer to identify the known temperature of the hot water and compare it to the reading registered from the CCTV thermal application. The test conducted implies that the temperature reading is able to meet the margin of error of 5% after the OpenCV color map applied to the thermal output pixel data. We conducted the project testing in Barangay Healthcare Center, and the project was evaluated by 10 panels of evaluators, composed of 10 barangay nurses. During the evaluation, we showed how the operator can monitor easily the thermal and true images on the laptop. Evaluators tried the system and subject themselves on temperature screening. Through their observation, system can operate remotely by the user without being near on the person under temperature screening, while the visual and acoustic alarms will only be activated to alert the operator when the presence of a person is elevated body temperature. They were given evaluation tool to rate both a specification of software and hardware, and the overall project was rated very good. Therefore, the researchers concluded that the project is very acceptable for actual product implementation to help the community. We aim on this undergraduate study to support our community and our people to improve our response in this pandemic and to help industry to go back to normal.